Alright, getting ready to lay up a Bellcrank mold here. This is what I was doing before, 15 years ago. The exact same process. Now you could probably alter it now if you could find something better as far as the resin or process, and I'm not going to deny that, but anyway, this is what I used to do. So I just brushed in EPON 815, which is an EPON 828 with a diluent in it. So it's got a lower viscosity. And I'm not sure of the centipoise, probably around 500 or 600 centipoise. And you got to remember water 0. And 1,000 to 2,000 is a normal resin. So when I was doing this, I was taking the 815 and I was mixing it with a Resin Services HT386. And the 386 curing agent was a high rate of per hundredweight, it's 33%. So the curing agent is a very thin, watery thing anyway. So when I was taking the 815 that was thinned out, and I was adding 33% curing agent to it, it got really thin. Now fast forward to now, 2020, I think if you had to replace that resin, the 815, with a resin today, I'd look to a high temp resin infusion resin. So they got resins now that are formulated for vacuum infusion. And what that entails, you put the fabric in the cloth, medium, peel, ply, you get the sandwich structure all laid up, and then you have like a air distribution media that actually allows the vacuum to penetrate into the bag deeper. And then you pull a vacuum in a bag, and once you get that vacuum pulled, then you open a valve, and the vacuum is what sucks the resin from a pot into the layup. And it's a tricky, it takes a little trial and error and a little knowledge, because what happens is if you don't have the vacuum right and the layup set up right, what will happen is you won't be able to pull the vacuum enough to pull the resin. And the resin needs to be really super thin. This little pin right here is not sticking out very far. It's not helping me out. So anyway, that's what I'd look into. I'd go to a resin that was around 500 centipoise, that would have a heat deflection temperature between 200 and 300 degrees. And I think you'd be able to reproduce the properties of this Bellcrank with the resin. And what I was doing back in 15, 20 years ago, I couldn't really find anything that would work for this Bellcrank, so I started formulating my own curing agents and resins. And this is what I came up with. It worked out great. But today, like I said, just look into a Vartem or resin infusion resin that's high temp. And I don't know if you can tell by the what's on this camera or not, but this carbon gets really super wet out. This resin is really thin. It doesn't even string. It just pull the brush out and it runs right off. And you can see where I use the edge of the mold to help wet out some of these fibers. Don't be afraid to overload these fibers just a little bit, because you can squeegee the air bubbles out and you can wet this fiber out in the mold, but then also you can peel it out a little bit, roll it around. So let's see, I've got one lap, turn, go straight. So this one, I'm going to come to the outside. So let's see, I've got 6 minutes. If I remember right, when I'd lay these things up, I try to shoot for 3 of them an hour. And that's not very many. That's just actual layup time. And then you had the PVA time, you had the demold, make the bushing time. So I'm guessing, I don't know, maybe by the time start to finish, even in a production process, you know, you're looking at an hour per part. And that's a lot of time on a little part, but I really couldn't figure out a way to get the part I wanted without going through all this. This toe that I'm laying in here is 320K, and a heavyweight fabric and a carbon cloth, you're looking at 12K toe. And so if you take 12K and then you bump that up to 320K, that's what I've got. There's 320,000 filaments of carbon each time I go around this bell crank. So there's a lot of carbon packed into this mold. And don't worry about getting frayed up. You're gonna have to go back and work this stuff down in there. So don't be afraid to utilize the edge of this mold here to wet this carbon out. And one of the advantages of putting in a surface coat in this mold over on top of the PVA that's already on it is it gives you a lot of abrasion resistance to lay this part up. You can see how I'm poking around this mold, but I'm really not getting to the PVA because the PVA is buried under this little surface coat I've got. And if I was trying to lay this up without that surface coat, I'd be digging into the PVA probably, and that would jeopardize the release in the part. So not only is the surface coat cosmetic, it allows you to lay up the part like this without breaking the PVA, because on this little part there's a lot of poking around to get this thing packed in there tight. So there's 3 times around the mold, and I come back and I usually end it where I started. Or I don't usually, I always do. So come back here and I split it, go around the post one last time there, take it out here again. Pack that in. And another thing I'm going to do here in a minute, there's some little voids around here where, you know, the carbon doesn't fill the mold exactly. I go through there and add chopped carbon. And you can see where it really doesn't want to stay in the mold. So don't worry about that right now, as long as you've got it predominantly in there. Don't be afraid to really push hard either. Take your fingers and work that toe down in there, and you'll see the resin bubble up. The resin will come out. Sometimes you'll feel air bubbles and voids come out, and you can also squeegee, you know, like this, lengthwise. So work this stuff, and you can tell by feeling it, you know, if it's really getting wet or dry. And don't be afraid to put pressure on it. That's where your strength is going to come. You want to get a lot of carbon in there and packed in that mold. So I've got a lot packed in there, but there's like little voids right up here. But there's a lot going around the pin, so that's good. I got all this, which is where your strength comes from. So then I go through here and add a little bit of chop. And just a little pinch there. Put a little chop there. A little there. Now even though this is chop, it's 3/16, maybe an eighth, I don't know. Even though it's smaller, it's still adding strength. So there is no resin-rich areas. It's just some areas have shorter carbon, like these little voids, and down in that, around the bearing where the recess is in the mold, that's chop, just to fill up the button. But it's pretty much all carbon in this mold, not any filler, just 100% carbon. And sometimes with the chop, try to utilize the squeeze out around these poles as the wetting epoxy for this chop. So this chop will end up sucking up some of this extra resin. So you don't have to add more. You might, depending on how dry you get it, but if it is a little full and you see just a little squeeze out, don't worry, because you put this chop in there, chop fibers, and that stuff will suck it up really nice. So you can see how it's really packing good now. It's starting to lay down. And the other thing the chop does here is this chop, it sort of interweaves in these long strands, and it holds it from popping out. And that was just a real quick squeeze out to give you a flat surface. And then I immediately put the plate on. And what I just poured on there ends up flowing out anyway. So that gave you a good surface on the other side, the bottom.